This is the video that goes along with the PowerPoint A for Chapter 15. And Chapter 15 is about energy and chemical chains. So we'll start out by defining energy. Energy is the ability to do work. I've got several types of energy. First, potential energy. If there's an object at a certain height above the ground, it's got potential to do things because of gravity. We call that gravitational potential energy. We're not going to deal with that as much as we are chemical potential energy. Chemical potential energy is the energy stored in bonds. So, if you're asked where that energy comes from in a chemical reaction, it's from the bonds. Another type of energy would be kinetic energy. Whenever you have potential energy, you have the potential to have something move. If I had this at this height, I let go, it would start moving. As it moves, it loses the potential energy, but it gains kinetic energy as it moves faster. To represent heat energy in this chapter, we're going to use the letter Q. And I strongly suggest that you make some flashcards or go over the different formulas and make sure you know what each of the letters represent. I'll give you most of the formulas, but you've got to know what the letters represent in the formulas to use them. When we measure heat, you can't measure heat like you do temperature. There's no heatometer that you could put into something and measure its heat. Heat has to be transferred in order to measure it. And when we do that, of course, we're going to use a calorimeter, and we'll be doing a lab where we use a calorimeter to measure heat. Heat energy is proportional to temperature, but it is not temperature. Temperature and heat energy, when one goes up, the other goes up, basically. You measure temperature with a thermometer, and temperature is the measure of kinetic energy. So we talked about heat transfer. There are three main ways that heat transfers. You should know these three ways. I don't think there's a question on the review about it, but there will be questions on the quiz and the test. The test is over all the stuff we covered, including the notes. So just make sure that you review over these. Conduction is transfer by touch. Convection is transfer by currents. Like above a campfire, you see the embers go up and then they go out. And of course the air is sucked back into the fire, and we have these circular currents we call convection currents. Finally, radiation, that's the transfer across open space. Could be in a vacuum, could be through air. You feel the warmth of the sun, that's by radiation. As far as measuring heat, we use the calorimeter, and calorimeter for us is going to be no more than a styrofoam cup with 100 milliliters of water and a thermometer in it. In general, we would put it in a beaker to help give it a little stability so it doesn't fall over. The purpose of that is we know the specific heat of water, we know the temperature of water because we've got the thermometer in it, and we know the mass of water because we've measured that. When we add something hot to it, we put something into it, and heat transfers, we can measure how much the heat of the water changes. That tells us how much heat the object gave us. As far as measuring, we always have to have units. So there are two main units we're going to use to measure heat. One is the calorie, and the other is the joule. Now, the question on the quiz and test will be, what's the SI unit of heat? That's the joule. But we also use the calorie, and it is part of what was the setup for the metric system. So maybe a little puzzle. I guess there was a choice between two this time, but they selected the joule as the SI unit. And that's what we use the most. The calorie is defined as the amount of heat that raises exactly 1 gram of water, exactly 1 degree Celsius. So be careful with that definition, because there's a definition for specific heat later on that sounds a lot like that, and you should look at those two definitions to make sure that you can separate them and know the difference. One big difference on calorie, it is a unit, and it says that in the definition, and it's also just for water, where specific heat is for all substances. So like we said, the SI unit of heat is the joule, And since we're going to be using the joule and the calorie, you need to be able to convert between those. I will give you that factor, 4.184 joules equals 1 calorie. You need to be able to build conversion factors from that in order to do the dimensional analysis. And you'll probably have one of those on the quiz where you have to convert. Whenever we use the calorimeter, the concept that you need to get in your mind from the start is that the heat that the hot object puts in the water is equal to the heat the water gains. So Q of water equals Q of the object. Q is heat, of course. So one of our main formulas whenever we have a temperature change is going to be Q equals MC delta T. So to write the formula for a calorimeter, first thing you want to do is say MC delta T for water equals the MC delta T of the object. Morning. Specific heat. That's going to be an important topic that we cover. You need to understand about specific heat. And probably the easiest way to think of specific heat is to think of a big cup and a little cup. Big cup is the specific heat of water. Water has a high specific heat. Something like metal is like a small cup. It has a small capacity. Specific heat is actually short for specific heat capacity. And it is just that. It is tells you about the heat capacity for a certain substance. Water holds lots of heat, and it takes lots of heat to make the temperature go up. Like a big cup takes lots of water for the level to go up. We consider maybe the top of the cup to be a high temperature, like 100 degrees. Where steel is like a small cup, we don't need to put much heat into it. Boom, it goes right up to a high temperature. Think of even amount of water. So let's say you have a metal pan that you put on the stove, and you have some water you put on the stove. Burners are the same heat. A minute later, you wouldn't want to pick up that metal pan because it's picked up high temperature quickly. It is a small container of heat, small specific heat. It gets hot quickly, and it loses its temperature quickly. Water, on the other hand, you can put your hand down in that water after a minute, and it's not going to be too hot. But when you turn off the burner and you take both of them off, the water will stay hot for a long time, where the spoon, maybe 10 minutes later, you'll be able to pick it up because it'll be cool. So it picks up and loses its heat quickly and raises and lowers its temperature quickly. Small specific heat. So when we don't use that MC delta T equals MC delta T, the other formula, if you're given heat, mass, and temperature of an object, would be C equals Q over M delta T. And you're going to be given Q equals MC delta T. You need to be able to shuffle that around to solve for C. Some example heat problems. First of all, probably one of the main things that you need to be able to do in this problem is, just like in most chapters, you're going to have to pick what type of solution or what type of method for solving a problem should I do. One of the first things is you should look at a problem and say, is it solving for heat? If the answer is yes, then the next question would be, does it include a temperature? If it includes a temperature or temperature change, you're going to be using Q equals MC delta T in some form or other. So this problem says how much heat is required to raise the temperature of 10 grams of water from 0 to 100. You have a temperature change. Q equals MC delta T. So it says water, so we know that C, which is specific heat, is equal to 4.184 joules per gram degree Celsius. That is a number that you'll be given, but you need to be familiar with it. That's the specific heat of water. The letter C is specific heat. That's one that you need to be aware of so that when you use that formula, you know what it stands for. So we've got Q equals MC delta T. That would be 10 grams times 4.184 joules per gram degree Celsius times 100 degrees change, because it goes from 0 to 100. Multiply all that, we get 4,180 with 3 significant digits. So another problem. It says, what is the specific heat of an unknown metal if 10 grams of the metal originally at 100 degrees. It's thrown into a calorimeter. Little alarm should go off, ding, 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 calorimeter problem, and you've got MC delta T equals MC delta T. So there are two ways to solve these. This one we're actually going to do a little differently. Because Q of water equals Q of heat, you could actually solve for the Q of the water separately instead of setting the MC delta T's equal. And that's what we're doing on this one, just to give you a little variety. You could solve it either way. So the first thing we do is we figure out the heat of the water. And that would be 100 grams of water, 4.184 joules per gram degree Celsius, and 5 degrees is how much the water went up. So once we solve for that, that's 2,092 joules with two significant digits because of the 5.0. Now we take that Q and we put it into the C equals Q over M delta T. It's the same thing as setting them equal, because basically what we did is we just said we solved for the heat of water. The heat of water equals the heat of the metal, so then I plugged it into the other MC delta T. So same deal, and when you see that problem on the example heat problems, look over it. You could work it with the other method. Doesn't matter. You just pick one of those methods. That doesn't work for you, go out to the tutorials out on the website or come in tutorials in class. And that finishes us up for that first PowerPoint. We just really covered through most of the first section. And we've got 3 PowerPoints in this chapter, A, B, and C. They're all online, and there will be videos out here for each of the 3. So try to see all of them. Stop them when you need, rewind, do what you need in order to pick up the information on the chapter. Good luck.